Hello, everybody, and welcome to another episode of the podcast. So, for those that don't know us, or for those coming back, just real quick, I'm Mark, and with my wonderful co-host, Shashank, we talk about Gen AI, like in general. So, we run a meetup in Silicon Valley, and it's a weekly meetup. We meet a lot of cool people, and we talk about a lot of interesting concepts. So that's why we made this podcast. We wanted to bring those interesting conversations that we had with the world, hence you. So we hope that you're able to get some, you, like as in you, the listener, we hope that you're able to get some value out of our conversations. So today, we were thinking about talking about agents. Like, what is an agent? What's an agentic workflow? Why they're kind of like the new hot topic. And then like maybe what are some kind of like things that agents will enable. Now, the reason we are talking about this today is shameless plug. We have an event on the 25th of July this month. So that's like in, what is that? About 2 weeks from today. We're going to have an event in Palo Alto. You can find the event details on our meetup page. We'll put it in the description, but it'll be meetup.com/gen-AI. You'll be able to see it there. It's going to be a workshop all about building agents. So hopefully we'll be able to see you guys in person on that one. But regardless, let's get right into it. So, Shashank, do you want to start us off and kind of maybe describe like what is an agent?
Sure. Yeah, I can take a stab at it. So we started seeing agents actually as early as 2 years ago when ChatGPT first came out, and people started trying to think of what are the limitations of this tool and how do we augment it. So some of the obvious things that an LLM can't do is search the internet, or at least back then, the LLMs couldn't search the internet. Now they have these functions or plugins, whatever you want to call it, that augment its capability to give it tools and ability to do other things outside of all the knowledge that is contained within the LLM's neural network. So using tools in a structured format to do repetitive things is usually something that can be automated by an agent. So let's take a use case. Maybe you want to summarize the top 10 articles in New York Times every day rather than going through it manually. So you can build an agent with this specific use case in mind, which has a bunch of repetitive workflows. You scrape the web, get a list of articles, you go through each article, summarize it, and return the summary in like a coherent manner. So an agent is something that can run multiple queries with an LLM by itself or call other functions outside of the LLM, do a bunch of processing, do a bunch of self-correction, and then return an answer after doing multiple steps.
Yeah. So one thing to note is it's not just like, one task. So Shashank gave the example of summarizing the New York Times, where it just like maybe it would be like a one-step thing where the agent would go and pull the articles from the New York Times and summarize them and then just do that once. But like you can do it where there are like maybe multiple steps. So for example, maybe you wanted to make an agent, if we're taking this example a little bit further, to give maybe like a commentary or maybe like fact check each of the articles in the New York Times, right? So like maybe the agent would go for each of the articles. It would go maybe article by article, and then article one, it would go and then maybe do look at it, summarize it, and then maybe we would do a Google search on each of the maybe key arguments made, and then try to see if it could find maybe some supporting data for that, and then maybe aggregate a list of like, I don't know how you say it, like a list of sources or like articles or whatnot to validate the coherency or like the truthfulness of a particular article. So like it could be like multiple steps, and then like that's kind of like a contrived example, but like you could go and build like a lot of really more somewhat complicated workflows. So like in addition to like fact checking articles, you could use it maybe for like investment research. You could do things like product research. I think like research is like a pretty good thing. You could do Google searches, maybe call like a calculator, call APIs that it don't like, maybe like a flight API. You could get access to calendars, maybe like movie showtimes. Maybe you could ask it a survey question to get like human feedback. There's like a lot of things that you could potentially do with this and try to combine them all together with LLMs.
Yeah, so apart from tool use, it can just borrow a lot of software engineering principles. It can like be asynchronous. It can do some LLM processing, wait maybe for like some relevant information, like you mentioned, to some user input maybe, or wait for a specific time, day, and then run a little bit of computation again. It could also get around some of the other limitations of LLMs, which is like the context window. So if you're thinking about a lot of data, a lot of maybe websites, a lot of PDFs, your LLM's going to run out of context at some point, even though these LLMs are getting really big today. But another way to get around this with an agent would be to store some kind of memory with key information that the agent can keep referencing over time, and use other types of information augmenting, like retrieval augmented generation, build a RAG, and then the agent can pull relevant information out of that RAG. So a lot of other tools can be added on top of these LLMs, and the agent can leverage these things to do higher level thinking.
Yeah, that's right. So like, I think we've kind of described like agents at like a little bit like a high level, but let's kind of like sort of guide the listener to think about like, hypothetically, let's just do like a thought experiment. Like, how would we somewhat build an agent? And let's think about like, what's the sort of possibilities of them. So like one thing that I was sort of thinking about is like doing having an agent for product research, right? Like how would we go about and like build something like that? So like I was thinking about it for a little bit, right? And with like product research, like let's say like I'm a company, right? And I want to figure out like what is like a good product that I want to be able to sell, right? So a good product to sell, like there might be certain things that like make a better product to sell than other products. So let's say like you're looking at the total universe of products and you want to see like, what may be good. So one thing you might be looking for is you might be looking for like maybe Google Trends. Like maybe somebody's like talking about like a particular product or a different particular type of product, right? So like, let's say it's like summertime and it's like Frisbees and everybody wants to go buy a Frisbee. So what the agent could do is the agent could maybe come up with, there could be a singular agent that goes and just looks at, let's say, products that like exist. And then maybe it could just go and then look at the Google Trends for each product and then see like if the trend is good. And if a lot of people are talking about Frisbees, or maybe another agent could go look at like the weather forecast and then see that, or like maybe the time of season, and then say like, hey, the season is summer, more people are outside, and then it seems like searches for Frisbees go up. That might be like a really good product that could be useful for the summer, something like that.
Yeah, that's a good idea. What other things could you add on to this agent? So you have some market or demand discovery. Then you come up with a few hunches for what kind of products would make sense in that time and location. Would the LLM be deciding that? Would you be pulling information from somewhere else?
So I think that you could ask the LLM to decide it, right? So you could have an LLM where you say like, hey, given like all these factors, let's say, for example, given a lot of people are talking about Frisbees in the summer, a lot of people are maybe giving positive sentiment reviews to frisbees on Amazon.com. Maybe a lot of people are giving like a lot of like maybe frisbee videos have recently gone viral on YouTube, and they're also trending. Like these three things made it so that we feed all that thing into the LLM and say like, hey, LLM, what do you think? Do you think this is like a good product to sell? And maybe they would say, the LLM would say, yeah, that seems good. But maybe you'd given the alternate example, like, oh, okay, like nobody's talking about horse and buggy. It's a really slow way to get around. Plus, it's snowing outside, so the horse gets snuck in the snow. Maybe that's not a good product. So the LLM would say like, no, I don't think this is a good product.
Yeah, I think it would definitely weed out the two extremes. It would definitely say, okay, no horse and buggy in 2024, not trending topic, unless it becomes hip again with some viral Instagram meme. But it can also detect obviously correct answer, hot, summer, sell sunscreen, frisbees, bathing suits, etc. It could maybe take it a step further. Since it's an agent, it could maybe put out some Google ads to validate, okay, is this a truly popular product, especially with all the other competitors out there, and check, the click-through rate, analyze that information, and then, give you some kind of a market research analysis too. But I feel like these LLMs in general, which are powering these agents, are somewhat limited in nuance. So do you think it would be able to detect some unique opportunities that don't exist? I feel like that's often a challenge because these LLMs are very easy to be primed with existing information. So if it sees a lot of keywords for frisbees, for example, it'll be like, okay, frisbee is the only thing that I'm going to think about for the next 10 prompts.
Yeah, that's a good point. I think that the LLM probably really good at finding what's popular, but it may not be able to figure out what that next big thing is that hasn't been invented yet. I think I agree with you there because I think that like certain things, like if the LLM had never been trained on it, I'm not seeing that it would necessarily be able to come up with the next iPhone, for example, right? Like, because the iPhone, when it was first created, was like so much different from everything else. I mean, you could say like, sure, like there was MP3 players in the past, there was phones in the past, but for it to combine those together, I don't know. I'm not seeing that it would be able to come up with that.
Yeah, I don't feel like it can either. Yeah. I feel like it'll probably get stuck in the same cycle of, priming itself over and over again with one keyword that it starts with.
Yeah. So I think maybe but if you're like a drop shipper who just are like reselling items, or you're selling something that is already like an established business model, I think this would probably work pretty well. Actually, it kind of reminds me. So I tried building an agentic workflow a couple weeks ago where I was playing around with some agentic tools where it would allow you to build agents on top of... Actually, I was using Olama. So Olama is a tool that allows you to run LLMs locally. It's an awesome tool. Basically because it was running through my OpenAI build way too fast when I was calling it. So I decided to run it locally. And I wanted to build a stock researcher. So I wanted to say like, hey, like, is this stock like a good buy? And just tell me everything you know about it. And unfortunately, the agent that I built kind of got stuck a couple times. So what was happening is I said like, hey, why don't you do some research on, let's say, Tesla? And then it would start doing some research on Tesla. It would do some cursory stuff saying like, oh, like it looks like the price has been going up, but the price has been going down. But then it started going off and like down all these rabbit holes. Like it started like going off and like looking like at, it's like, oh, Elon Musk is the CEO of Tesla. And then it started like, reading a bunch of articles on Elon Musk, and then I started reading all these articles about batteries, and then I started reading all these articles about like Tesla cars and the problems of the cars, and it just like wouldn't stop. It just kept going and going and going, and then I think my computer eventually ran out of memory. So maybe like if I had a more powerful computer, like it'd be okay. But yeah, it just got stuck, and it kept going. So as like an aside, like in computer science, there's like the concept of like depth first versus like breadth first search, and like also like recursive problems. So like briefly, when we talk about depth, we're talking about like it's like a graph structure. I don't know the best way to describe this, but basically it's kind of like sampling all of the little topics a little bit. So like, for example, if I was like a person and I was what you call like person who was into a lot of things. So like maybe like I'm into cooking, I'm also into sports, and I'm into programming, and I'm into I don't know, woodworking, and I'm into like, I have a bunch of hobbies, and I just know a little bit about them. I'm not really that good at them, but I am just a little bit okay at each of these things. But then there's so that's a depth first. So like I'm just like a little bit deep.
That's breadth first.
Oh, sorry, breadth.
Yeah.
My bad.
You have a breadth of interests and hobbies, so you're skimming a little bit
right
off the top of each of these different things. Whereas breadth, whereas depth first, as the name indicates, you would go really deep into one particular area. You're obsessed with climbing, let's say, and then you're just watching climbing videos. You go to the climbing gym, working on your little dead hangs, building finger strength. So.
Right, exactly. So I feel like the problem is like when I was running these agents, it was doing the problem of both. Like, so it was doing too much breadth, and also too much depth. And it would never actually tell me if Tesla was a good buy. It just like kept on going. And I think that's like kind of a fundamental problem with agents is like it's kind of hard to tell it when to stop. I think like at the beginning when you mentioned like summarizing New York Times articles, that's something where it's like pretty clear. It's like, okay, like here's like a clear stopping case. But if you're doing like product research, like you can just continue to do research. Like I can just like keep on learning more about Frisbees and just like keep going. It's hard to know when to stop.
I guess that's when you need to really spend some effort into building this orchestrator that manages this individual pieces within the agent. So maybe something that would keep tabs on how deep or how many times it's thinking about a specific product, specific stock to research. And if it's doing it too many times, be like, okay, this is a good enough stopping point. Let's move on to something else.
Yeah, that's true. But sometimes I feel like none of those things are actually going to give you the answer that you're looking for, because it's just like, if I say like, I want to look for Tesla, and then like it starts going off to Elon Musk, then it's like, you could just like keep going down that rabbit hole forever. And then like you have to tell it to kind of come back up and sort of stop, even though like doing all that information on Elon Musk never actually told you if Tesla's a good buy, even though it's sort of related.
It's tangentially related. Yeah.
Exactly.
So I guess you would, if you were a human being with some common sense and some basic understanding of market research or finance, you would get enough relevant information until you started getting diminishing returns maybe, and then decide, okay, I know enough about this topic, let's move on to something else.
Yeah, that's right. But then, like, at the end of the day, sometimes you just, like, would chalk that up as, like, a risk, right? It's because, maybe, there's, like, a key man risk, I think, at Tesla, where, like, if Elon Musk got hit by a bus tomorrow, Tesla might tank because, he is kind of, like, the face of Tesla and is, at least from the outside looking in, it seems like he makes, like, the majority of the kind of the key decisions there. Right. So it's like maybe like a human like investor be like, all right, that's a risk that like Elon Musk has so much power. And then maybe like the LLM would like try to factor that in somehow. But that's kind of like a hard thing to program for.
Yeah. So I feel like if you're building an agent, you would want to list out specifically what the agent should be doing. So you mentioned, what is it, like something in finance to call out risk of like an individual leading the company. So what if that person, dies, God forbid, or something happens, they get bored, they leave. To try to codify these list of indicators for this company and have the agent go through each one of these indicators and see if this company, mitigates this risk or is in danger for this thing.
Yeah, that's right. Although I think the problem is like when you're making the agent, like I mentioned key man risk, and like you could probably code in like, hey, like key man risk and put like a bunch of heuristics.
I think we're trying to get away from that, from the regular traditional software engineering principles,
right?
And have the agent be truly intelligent, come up with these requirements by itself.
Right, exactly. And then that's the hard part in like figuring out like the determination. Because another thing that I noticed when working on this same agent that I was trying to build is it would occasionally get stuck. So like basically, you would have the LLM try to figure out the next prompt for the LLM again. So it would kind of like recursively call itself. But then sometimes I would find that it would get into sort of local kind of like tops where it would start to just like start getting like loops where like it would say a thing and then like it would go and then say another thing and then come back to the same thing that it said. So like I mean, it didn't do this, but like an example of like a loop would be like, we think that like Tesla has key man risk. And then like, it would say like, okay, like the key man risk is Elon Musk because Elon Musk is in charge of Tesla. And because he's in charge of Tesla, it has key man risk. And then it would be like, oh, okay, like what's the key man risk? And then it would be like, oh, the key man risk is Elon Musk is in charge of Tesla. And then like it would just keep on looping like between like key man risk and Tesla and Elon Musk and then key man risk and then Tesla. So it would just like keep on like recursing and then going back and forth. It would just get stuck. And it's kind of hard to get unstuck with that.
Yeah, I feel like, again, going back to having an orchestrator manage each of these individual, prompt engineered LLM personas, that really is important to make sure that the agent is making progress in the right direction. An alternative that comes to mind is to try to just interrupt it yourself, be the orchestrator to manage all these little individual characters to try to make enough progress and then stop them when you need to.
Yeah, that's true. So do you want to go into maybe a little bit detail on like what like an orchestrator is and like how that would be used?
Sure. Yeah. Actually, I can't think of an example. Let's stick with the same finance exploration.
Well, I would think that like to give an example of like an orchestrator, it would be like a product manager in like to take a software development approach, sure. Right? Sure. Or just like even like a manager, right? Sure. Right. So like a manager, maybe they're working with a bunch of different employees, and the employee does a bunch of tasks, or employees do a bunch of tasks. And then oftentimes they're working on different things all in parallel, not together. And then sometimes like the employee will go off and do their own thing. So sometimes the manager will need to say like, hey, look, like, hey, Timmy, like, stop it. Like, you're enough looking at Elon Musk. Like, just come back. And like, we've got enough. We'll just chalk it up as a risk and then move on, like, go continue your research. Right. And I think that like, we would have to have like an agent that acts as sort of like the manager to like make sure that all the other agents underneath don't go like out of control.
Yeah, that's a good way to think about it. So you built an agent that did something similar a while back. It was like a tech startup agent that took some high-level prompt to build an app, a game, etc., and then just boom, built it with a bunch of different, focused LLMs. One was a product manager, one was an engineer, one was a QA, I think. So I don't remember if you had an orchestrator, but that would be a perfect use case.
I did somewhat. I had a product manager that would help.
So that is the orchestrator.
Yeah. Okay. I didn't call it the orchestrator. I didn't know what an orchestrator was at that time. But so you guys remember, I think it was Devin, which is the thing that would like do coding.
Yeah.
I made that like probably 6 months before Devin was launched. So you know, where's my $1 billion? But anyways, yeah, Devin's a cool thing. It was like a thing where I think it like used agents to be able to program.
Yeah.
And then didn't Microsoft buy them? I think.
Did they? I had no idea.
I thought so. I thought I remember hearing something about like Microsoft buying Devin. I don't, Shashank will do some research on that. I don't want to buys Devin. But anyways, basically Devin was like a cool thing where you could give it a prompt and then it would be able to just like write code. So I could say like, hey, Devin, make me a Tetris game. Hey, Devin, make me like a website that sells my products, and it would just build it.
Yeah, so in my mind, an orchestrator would be like the role of the CEO, maybe, who's one step above even the product manager. Because let's say we start out with a high-level description. I want a cool new game that is really trendy and relevant today. So maybe the business analyst would look at the top-performing apps or games on the app stores and see what kind of themes they have, send that information to the product manager who comes up with a bunch of requirements. And, you know, if the product manager was the orchestrator, maybe they would just keep coming up with requirements and keep refining each different requirement, go in depth until, like, you know, they take over, like, the whole operation. As opposed to someone being in check who doesn't have any other function as other than just to keep tabs on all the individual personas that are doing different tasks.
You know, that's a really good point. Yeah, I feel like the CEO is like a better example of an orchestrator. So, I don't know, Shashank, with all this being said, like how far away are we from just like, or if you had to speculate, like how far away are we from just like creating like an entire company just off of AI agents? And like, what do you think we're missing?
Yeah, that is a good question. I think Andrew Ng was really bullish on agents a couple months ago because we were like, okay, LLMs are kind of plateauing. They have similar limitations as they did maybe a few years ago. Some of the tools and functions, plugins, etc., that augment their capabilities have increased, but still they're not truly intelligent. They get stuck. They cannot accomplish higher level tasks. So a lot of people started looking into agents, and I think the first few versions of agents that were written up by a couple software engineers and posted on GitHub were called AGIs. It was like baby AGI or
yeah, I was looking to that source code a while ago. Yeah,
so we've been bullish about this for a while. I think it's possible. I just feel like the agentic blueprint framework to construct something that accounts for all these limitations, making sure it doesn't get stuck, making sure it doesn't go depth first into a rabbit hole, having checks and balances on each of those different personas that is doing work. If we solve some of those problems, I feel like we could get to AGI with the next version of ChatGPT that comes out. Maybe something multimodal that can understand and reason in different domains, video, image, audio, text. And if you put that into an agent, I feel like it would be pretty close.
Whoa. So like
a good agent.
You just said like AGI by the next version of ChatGPT.
And a solid agentic framework.
I mean, wow. All right, guys, you heard it here first.
I don't think that's trivial, though. I feel like that would take a lot of information theory and, some kind of game theory to make sure all these different personas interact well together. Some kind of economics or something to understand how different entities make progress towards an end goal, all of that stuff.
So 2025, AGI, it's happening.
No set dates, but my intuition is that stronger multimodal model with better agentic frameworks would get us a long way.
Yeah, I think multimodal is like a really big key. So I went to a hackathon, I think it was 2 weeks ago, where they were talking about the ARC prize. So have you heard of this ARC prize?
Is it from the browser?
So it's made by like a couple people. There's one guy who started Zapier. He was at the hackathon. He gave a little presentation about it. And then there's another AI researcher, which I can't remember his name.
Mm-hmm.
So they came up with this ARC benchmark. So basically what the prize is it is a set of tasks that show like puzzles that are arguably simple for like humans. Now, honestly, I don't think they're that simple. So some of them I thought were kind of hard. Maybe I'm just like not that good at these puzzles, but to me they were a little bit hard. But arguably, it's like something that like a human like could solve like without knowing any details. So like oftentimes it would be like stuff that you see on like an IQ test. So it would maybe like show you like a certain bit of I don't know how to describe it. Like it would have like a some sort of like n by n grid where like maybe like a 5 by like it would look kind of like Sudoku sort of. Like maybe like the Sudoku puzzle would be like colored, and then like it would be like Sudoku puzzle A is colored, with this set of patterns, and then Sudoku color B is colored with this, and then like how do you get from A to B? And they would give maybe like 2 or 3 examples, and then you'd be like, okay, now like here is like an unsolved one, like how do you solve it? So basically just like kind of like complete the pattern, but like in a multimodal way, and none of the LLMs right now are able to solve it more than I think like the number one approach to solving it was like around 50%, and that costs a lot of money, and it also was like a super brute force way of doing it. So apparently the way it was done is they made like 10,000 like a different like programs for each of the patterns. They just like brute forced it, and it worked pretty well. I think they got like 60%. So they argue that if they're able to solve these types of problems, that would either be enough of an agentic flow, maybe not agentic, but like that would solve enough problems in order to solve AGI. Not sure, but that's what they argue. And then maybe, so I'm guessing, what I'm trying to say is I think maybe something like that is what we're missing.
This feels very different, though. It feels like a computer science problem, maybe computer vision, or if you could code it into an n-by-n array. So for context, this ARC prize, it shows a grid of shapes, and there's an input, there's an output. You see some incomplete shapes in the input, and the output would be to complete it with a certain shade of colors. And as a human being, I can kind of like intuit it pretty quickly. We have like 3 dots in the shape of an L, and you put like the 4th dot and make it a square. So I was like, okay, fine. You take other shapes and fill in this pattern. I think this seems very computer vision like, or some kind of an algorithms task as opposed to AGI, because it doesn't contain any textual information. It's not reading anything. It's not reasoning about information in text. It's very logic puzzle based.
Yeah, I guess that's true. But I guess that, like, if you think about it, like, reading text isn't, like, I think necessarily required for AGI. So, like, humans, sure, like, even if, like, a human was illiterate, they would still be maybe smarter than, like, the LLMs that we have right now.
That's fair.
Like, maybe they could, like, talk, or maybe just, like, solve problems that, like, you wouldn't have been able to solve, like animals like can't, well, they don't use speech in like traditional like sense, right? Like dogs, for example, don't like talk. They bark. They like kind of talk in like tones, sort of, but they don't necessarily like talk in the same way we do. But I would argue that like dogs are like pretty smart, like in interacting with them. So I don't know. I guess I'm like not like really a fully formed thought on that, but
Yeah, now we're getting into what is intelligence.
yeah, exactly. But anyways, we're kind of out of time, so we don't have time to talk about that. But anyways, maybe we'll talk about the next one. We'll see. Anyways,
So maybe like a takeaway from this would be agents are cool, but they have a lot of limitations. I would say if you're trying to build an agent, it only makes sense if you have a very repetitive workflow that you can refine
yes.
and codify into specific instructions exactly what needs to be done. The more specific, the better performing that agent will be.
Yeah, I think that summarizes pretty well. So anyways, until next time.
Bye, everyone.